Texas, where the ground and sky refuse to stay quiet. Texas has always been a place where scale overwhelms the senses. The land stretches so far that the horizon feels optional. Skies open wide enough to swallow weather systems whole. Cities rise where cattle once moved, and oil derricks nod slowly beside highways humming with modern life. But beneath this familiar grandeur, something quieter and far more unsettling is unfolding. On an otherwise ordinary evening in East Texas, people stopped what they were doing and looked up. Around 5:30 p.m., a strange object streaked across the sky, fast, bright, and silent. It was caught on camera, replayed on phones, debated online. Some thought it was space debris. Others whispered about experimental aircraft or something stranger. Whatever it was, it left behind a familiar feeling Texans know well, the sense that this land still holds surprises. At nearly the same time, crews were rushing to a very different mystery near Paducah. A sinkhole, nearly 70 feet deep, had opened without warning. County roads were shut down. Barricades went up. By morning, the hole had grown larger. The ground itself seemed to be quietly pulling away. Elsewhere, scientists were rethinking something far older and more powerful than either mystery: earthquakes. For decades, researchers believed they understood how seismic events build and release pressure. But new findings from the University of Texas suggest that some long-held assumptions may be wrong. The Earth, it turns out, doesn't always behave according to our neat models. Taken alone, these moments might seem unrelated. A flash in the sky, a collapse in the ground, a revised theory in a laboratory. But together, they point to a larger truth. Texas is not just a backdrop for discovery. It is becoming one of the most active frontiers of modern science. Beneath mesquite-covered ridges and sagebrush valleys, deep underground signals are stirring. Along the remote Gulf shoreline and far offshore, researchers are uncovering changes that challenge what we thought we knew about land, sea, and life itself. While many eyes remain fixed on distant galaxies, scientists are increasingly turning their attention here. What they're finding is both awe-inspiring and unsettling. Unfamiliar seismic patterns, shifting coastlines, ancient life, forms thriving in total darkness, vanishing water, forces that operate slowly, silently, and far below the surface, yet shape everything above them. Texas has always been a land of extremes. Now, it is revealing extremes of knowledge. Each discovery expands the boundaries of science while raising new questions. When technology allows us to see deeper into the Earth and farther into the universe, can we be certain what we will find? Are we uncovering stability or fragility? The ground is shifting, sometimes literally. The waters are changing. The sky itself seems to be offering clues. From beneath our boots to far beyond our atmosphere, Texas is rewriting what we understand about geology, biology, climate, and the cosmos. So before these mysteries slip quietly past us, before they are normalized or forgotten, it's time to take a closer look. These are not legends or rumors. These are documented discoveries, active research, and unfolding events. This is the story of Texas as scientists are seeing it right now. 5 chapters, 5 frontiers, one place where the known world meets the unknown, beyond the horizon, Texas and the edge of the universe. The story of Texas's strangest discoveries doesn't begin underground. It begins light years away. In 2024, a research team with strong roots in Texas announced something extraordinary. Using advanced telescopes and data analysis techniques refined at Texas institutions, they identified what may be the most distant galaxy ever observed. The light reaching Earth had traveled for more than 13 billion years, emitted when the universe itself was still young. That faint signal, barely distinguishable from background noise, carried a message from the dawn of time, and Texas scientists helped decode it. This discovery placed Texas firmly on the cosmic map. The state is no longer just a contributor to space science. It is a launch point for humanity's deepest questions. Who were the first galaxies? How did structure form? What came before stars as we know them? But cosmic distance was only one side of the story. That same year, another Texas-based research group made headlines for something that once belonged strictly to science fiction: invisibility. By engineering advanced metamaterials capable of bending electromagnetic waves, scientists demonstrated ways to guide light around objects rather than reflect it. This isn't the fantasy of vanishing humans, but it is a real step toward cloaking technologies, improved sensors, and revolutionary revolutionary optics. It could reshape communications, defense, medicine, and astronomy itself. What connects these breakthroughs isn't coincidence. It's infrastructure. Texas hosts some of the world's most powerful observatories, laboratories, and computing centers. It attracts researchers willing to challenge assumptions and chase ideas others consider impractical. Under Texas skies, so vast you can almost sense the edge of space, humanity is learning how to see farther and hide better at the same time. One discovery pulls the universe closer. The other teaches us how perception itself can be rewritten. And this is only the beginning. Beneath the surface, the quiet power of Texas geology. Texas is famous for oil, gas, and wide open land. But beneath that reputation lies a geological story far older and far stranger. In the Dallas-Fort Worth region and beyond, geoscientists use seismic tomography to peer into the earth without digging. Their images reveal ancient seabeds, brine-filled channels, and loosely packed formations shaped when Texas lay beneath shallow oceans. These are not catastrophic voids, waiting to swallow cities. They are subtler, and more important than that, they guide water movement, influence ground stability, and quietly shape how cities grow. As groundwater is pumped for agriculture and expanding cities, some regions experience gradual subsidence. The land sinks slowly, almost imperceptibly, until cracks appear or sinkholes form. Insurance companies track it. Engineers plan around it. Scientists study it. This hidden movement is not a sign of failure. It's a reminder that Texas rests on a living foundation, constantly adjusting to pressure, weight, and time. Farther west, in limestone country and oil fields, drilling has reached layers hundreds of millions of years old. There, researchers discovered something even more astonishing: life. Deep underground, in salty aquifers sealed from sunlight and surface air, ancient microbes survive by chemistry alone. They draw energy from minerals and hydrogen, thriving in darkness. These organisms are not dangerous. They are miraculous. They show us how life might exist on Mars, Europa, or worlds yet unknown. They have sparked collaborations with NASA and biotech researchers eager to understand resilience at its most fundamental level. Every core sample pulled from Texas soil carries not just data, but history, stories written long before humans walked the land, shifting shores and restless waters. Along the Texas coastline, the land itself refuses to stay still. The Gulf of Mexico is a dynamic force, reshaping the coast through storms, tides, and currents. Satellite imagery over recent decades has revealed sandbars and temporary islands forming near river mouths and after hurricanes. These islands are fleeting, built from sediment. They may last months or years before vanishing again beneath waves. Birds land first, then plants, then the sea returns. The Coast Guard monitors these changes closely. Navigation channels shift. Habitats appear and disappear. Fishing grounds evolve. Above the water, another phenomenon has drawn scientific attention: ocean heat domes. In recent years, Gulf waters off Texas have remained unusually warm for extended periods. These trapped heat zones reduce oxygen levels and sometimes trigger marine die-offs. Warmer seas also fuel stronger hurricanes, intensify drought cycles, and amplify flooding. Texas sits at the crossroads of these extremes. As reservoirs drop during dry years, exposed lake beds reveal ancient tree stumps, fossils, and even petroglyphs. Mammoth bones emerge where water once stood. Coral fossils appear far inland, reminders of eras when Texas was underwater. The land remembers everything: the ever-moving earth and the future of discovery. Texas may not be famous for earthquakes, but it is far from motionless. Across South Texas and the Rio Grande Valley, GPS sensors detect subtle shifts along ancient fault lines. Most tremors are too small to feel, but each one teaches scientists more about stress, movement, and safety. In Central and West Texas, gravity readings and satellite radar reveal slow uplifts and settling. Some movements relate to groundwater withdrawal. Others hint at deep geological processes tied to ancient volcanic systems in regions like the Trans-Pecos. There is no imminent volcanic threat, but the rocks remember fire. In the Permian Basin and offshore Gulf, seismic mapping reveals thinning crust and evolving basins shaped over millions of years. These processes don't threaten cities tomorrow, but they define continents over time. Texas, it turns out, is not just a place where history happened. It is a place where Earth's story is still being written. From distant galaxies to ancient microbes, from sinking ground to warming seas, Texas stands at the intersection of discovery and humility. Science here is not about fear. It's about understanding. And the deeper we look, the clearer it becomes. The greatest mysteries are not always out there. Sometimes they are beneath our feet. Sometimes they are written